In this example, we're asked to integrate x times secant x times tangent x. This example actually illustrates why it's so important that you memorize your derivatives of the trigonometric functions. So we look at this, we see a product of functions where a straight u substitution is not going to work. You can't integrate this letting u equal to something and then writing it in terms of u. It's just not going to work. So plan B, when you've got a product of expressions like this, expressions of x, and u substitution is not going to work, then we go to what's called integration by parts. I like to abbreviate it IBP, which says the integral of u times dv is equal to uv minus the integral of v du. So, first step, which I've said it takes some practice, is dissecting this integral, deciding, okay, so what part of this do I want to call u? What part of this do I want to call dv? And the reason I said it's an illustration of why you should memorize your derivatives of the trig functions is because you need this secant x tangent x right here to jump out at you. You need to look at that secant x tangent x expression and say, that's the derivative. I know that's the derivative of a trig function. And more than that, I know which one. If this is dv, secant x times tangent x dx, then v must be, say it with me, no, nobody's with me. Okay, secant x. This is the derivative. So you want this to jump out at you, like, hey, this is the derivative of secant. So if I make that dv, then I know that v will be secant x. That's the hope. Okay, well then that means that u must be just the x. That's all that's left for us to call u. So u is x, which means du is just 1 times dx. Now apply that formula. So this original integral is equal to u times v minus integral of v times du. I guess I'm going to take these caps off again. My markers are drying up though. Okay, so u times v minus the integral of v times du. Okay. So now we just need to integrate secant x. So the integrals of just one individual trig function, this is a matter, right? This gets down to then either you know it or you don't. And if you don't know it, then you should look it up on a table somewhere. We've got a list of differentiation rules. And this is not one to panic if you don't have memorized at this point. So you could just go look it up. But so the integral of secant x dx is natural log of the absolute value of secant x plus tangent x. And again, going from here to here is just a matter of either you've memorized it, because your Cal 1 teacher did a good job of making you memorize all those integrals, or you go look it up on a table of differentiation rules. And this is not one where you should really beat yourself up too much if you don't remember. It's okay if you look it up. So this is your final answer.